Hey guys, how are you all? So if you have not subscribed my channel yet, please subscribe it. I'll be sharing a lot of technical videos on checkpoint firewalls, and it is in very depth level. So try to subscribe my channel, and I will see you there.
Hello guys, welcome to my YouTube channel Firewall Gan. My name is Vaibhav Parmar. I am handling checkpoint products over 10 years. Today I am going to present a very important topic, which is checkpoint firewall VPN troubleshooting. So let's get started. Before jumping to checkpoint VPN troubleshooting, let's understand what is VPN and key points. VPN stands for Virtual Private Network, which helps to interconnect networks that are physically not in same location. VPN connection is private, so VPN traffic should be encrypted. When we talks about VPN, we always refer few terms like peers. Peers are nothing but VPN devices or firewall gateways who established VPN tunnel between them. The devices performs encryption and decryption, and we call this thing as a peer. Also, you might heard a lot about term like encryption domain. People almost think encryption domain is something related to VPN encryption technology or technique, but it is not. Encryption domains are your hosts, hosts, network subnets, and other objects that have to go to the VPN tunnel so that remote site must access them. In simple words, encryption domains is your side and remote side subnets which user will securely access via VPN connection. During this video, I will be referring uh, your gateway IP address 172.22.102.1 as an interface IP address, and 10.2.4.0/24 as your encryption domain from your side. We all know IPsec. It is an open standard protocol suite for secure IP communication. It uses authentication and encryption technique on packets. Below are the protocol used to perform various security functions. These protocols are part of IPsec protocol suite. Let's understand authentication header AH. Authentication header basically used to provide connectionless integrity and data origin authentication for IP datagram. This is widely used to provide protection against the reply attacks. Next protocol is encapsulating security payload. We also refer it as a ESP. ESP not only provide connectionless integrity and data origin authentication, but also confidentiality. Also provide connectionless integrity, anti-reply service, and limited traffic flow confidentiality. Security association, we refer it as SA. Please note, SA is not a protocol. It is a data structure which provides the bundle of algorithm and data that are the parameter necessary to operate the AH and ESP operations. Internet Key Exchange is a key protocol used to drive IPsec protocol suites and framework. Let's see how. As we know, SA Security Association that provides this set of algorithms and the data that establish the parameter to use authentication header and ESP. IKEVIEW helps here to provide the authenticated keying material. Here SA provides the necessary framework for authentication and the key exchange, and IKEVIEW helps from creating initial tunnel, initial encrypted traffic flow, and that traffic flow is always unidirectional, as initially one SA forms. So please note, a pair of SA always required to form a tunnel that is bidirectional. IKEVIEW negotiation consists of two phases. Phase 1, which we called main mode, and phase 2, which we called quick mode. The negotiation process in both modes can be observed in IKEVIEW.elg file. There is an internal checkpoint utility called IKEVIEW. I will give you a link in a description from where you can download that IKEVIEW file. IKEVIEW utility, so that you can refer your VPN debug IKEVIEW.elg and the VPND.elg file, and open those files inside this IKEVIEW tool and see the various packet flow. IKEVIEW gives you details of initial packets flows between source gateway to the destination gateway, or you can say the local site to the destination site, which forms VPN tunnels or VPN tunnel. Let's talk about IKEVIEW phase 1. IKEVIEW phase 1 exchanges 6 packets, 3 from local site gateway and 3 from the remote site gateway. Let's understand what these packets contains. IKEVIEW phase 1 has 6 packets exchanged, and below are the details. But before that, let's understand the important term which we call VPN parameters. VPN parameters are the parameters which flows between the tunnels. To remember these parameters, I have given a mnemonics called haggle. Here H stands for hashing. Those are the hashing algorithms such as MD5, SHA-1. A stands for authentication. These are the authentication techniques such as DigiCert or pre-shared key. G stands for groups, Diffie-Hellman groups. L stands for lifetime. Usually these are in seconds in checkpoint, but some other vendor also refers in a KBs. And finally E stands for encryption, the encryption algorithms like AES, 3DS. Troubleshooting a VPN requires an understanding of the process of creating a VPN tunnel. Following is the IKEVIEW exchange process. Phase 1, main mode, negotiate encryption methods such as AES, 3DS, etc. The hashing algorithms such as MD5, and establish a key to protect message of an exchange. The following describes the various stages of phase 1. Phase 1 contains 3 stages. Stage 1, peers negotiate algorithms, authentication methods, and Diffie-Hellman groups. In phase 2, each gateway generates a Diffie-Hellman private key and public key and calculate the shared keys. In phase 3 or stage in a stage 3, peers authenticate using the certificates like a PSK. Each side generates a symmetric key based on the Diffie-Hellman key and the key material exchange between sides. Now let's see and understand the IKEVIEW stages with the packet exchange. Packet 1, it checks VPN proposal like encryption, hash, lifetime. Packet 2, this is response packet of packet from peer which gives agreement or disagreement for packet 1 proposal. Packet 3 and 4 perform key exchange. Packet 3 and 4 are the actual security decision maker because your actual key related exchange happens at packet 3 and 4, but these packets never ever helps you to give you any idea during your troubleshooting, because every time you see a large number formation which was never used before, and we call it as nouns. Packet 5 and 6 perform authentication between peers. If it is fail on this stage, the certificate or pre-shared key has to be checked. Now let's understand phase 2 quick mode. In a phase 2, peers also exchange key materials and agreed on encryption method and establish a key to protect message of an exchange. Phase 2 also has 3 stages of a key exchange. Number 1 stage, peers exchange more key material and agree on encryption and integrity method for IPsec. Number 2 stage, Diffie-Hellman key is combined with the key material to produce the symmetric IPsec key. And finally, number 3 stage, the IPsec keys are generated. Now let's understand the phase 2 packet exchange. Before to understand the packet exchange, let's understand the different parameter VPN parameter passes in phase 2. For phase 2 VPN parameters, I have given a mnemonics like HLIA. H is for hashing, MD5 SHA algorithms, L for lifetime, seconds or KBs, E for encryption, AES 3DS, A for agreed upon the subnets, which is encryption domains. I just brief you about the phase 2 phase exchange. These are the key points. Just quickly look and we will move to the next slide. Now let's understand the phase 1 packet flow with the example, and this is how the IKEVIEW tool shows you the packets of the VPN exchange, VPN tunnel exchange packet. Let's see. The packet 1 of IKE phase 1, you're seeing the IP address 172.24.104.1, which is your local gateway interface IP address, or the IP address which you refer as your main gateway IP address. Encryption algorithm used here is AES CBC as shown in the screen. Just refer the screenshot. This is the actual packet capture from the IKEVIEW, how the packet shows there. Then there is key length, which is 256-bit. Hashing algorithm used, which is SHA-1. Authentication is pre-shared. Let's see what the packet 2 says. Packet 2, if you see, it is a response from the peer. Here all parameters are matching, like your gateway IP address, encryption domain, key length, hashing algorithms, hashing techniques, and authentication method. When you do troubleshooting, or when you do the VPN troubleshoot, and or when you generate this file and you find first two packets are showing failed, then you have to check these details, like gateway IP address ID, which is the interface IP address of your gateway, and the peer, encryption algorithms, hashing algorithms, pre-shared key values. Packet 3 and 4 perform key exchange and include a large number never used before, which we call nouns. As shows, value of key is very huge number, so packet 3 and 4 are never used when you do the troubleshooting, and the number shown as a key payload is always get changed. So I can say these two packets are not that helpful for troubleshooting, because you are not seeing any details here, and I haven't observed the packet 3 and 4 fail sort of scenarios when we do the troubleshooting. Packet 5 and 6 performs authentication between the peers. The peer IP address shows in the ID field under packet 5 and packet 6. It shows the peer has agreed on the proposal and has authenticated the initiator. So if the packet 5 and 6, if those packets get fail, you have to check the gateway IP address and the authentication method what we have used, if there is any issue. Now let's understand the packet under phase 2 quick mode. Phase 2 packet 1, it proposes either a subnet or a host ID, an encryption domain, and the hash algorithm and the ID data to the peer side. in the ID field, if you see the highlighted ID field, the initiator's VPN encryption domain of the initiator, and the value is 10.2.4.0/24 subnet. So this is the value we are sharing as an encryption domain from your source gateway or a local gateway or your initiator gateway. And ID field 2 shows the peer gateway encryption domain network. If you see the phase 2 packet 1 or 2 fails, this is because of mismatch in an encryption domain. So you have to check the encryption domain mismatch, or you have to check the encryption domain at the both side what we are sending in a tunnel, and after rectifying it you will be seeing that error pass away. And finally, packet 3 completes the IKE negotiation. Common issues when we observe during the troubleshooting, those are as below. First one is mismatching the parameters. Second one, mismatching the proposals. The classic example is supernetting. Third one is your failed to fetch CRL. Fourth one is your some sort of certificate issues, and the link selection, or you can refer it as a wrong local and remote gateway IP address. So basically, most of the time VPN tunnels are not forms or gives issue because of the proposal mismatch, right? This is how you can use IKEVIEW tool to generate IKEVIEW tool to see the packets flow, like phase 1 and phase 2. Now let's see how you can generate a IKELG file for IKEVIEW tool. So at the left side you are seeing the commands and the explanation for it. First, turn on the debug with VPN debug trunk command, and VPN, the command is not shown there, but the VPN debug trunk command and the IKE debug on. So this starts your new debugging process. After running these commands, you need to reproduce the issue. You need to try to send some packets from your source gateway to the destination gateway to generate some traffic, and those traffic logs or the packet captures or the packet flow get stored into this IKELG file, and the location of the IKELG file is $fwdir /log/ike.elg, the file name, and the VPND .elg file name. Once this happens, you have to stop the debug with the command like a VPN debug off, VPN debug trunk off and the IKEVIEW off. After stopping this debug, the file which are located at the location $fwdir/log, you will get two files, IKEV.elg and VPND.elg. You have to take those files and try to view into the IKEVIEW tool, and you will see the actual packet flow and where which packet is failed and where it causing the issue. So these are a few steps or few details on a VPN troubleshooting.